Hello everybody. Today I am Karan Mittal and my other friend Irfan Ahmed Khan will help you understand forest data structure and multi-way tree. Here are some of the basic terms we need to learn before we start onto that. First of all, we need to know about a graph. A graph is a non-linear data structure consisting of nodes and edges. The nodes are sometimes also referred to as vertices and the edges are lines of arcs that connect any two nodes in the graph. Here you should know that nodes represent the data and the lines represent the connection between the two. A tree. Unlike arrays, linked lists, stacks and queues, which are linear data structures, trees are hierarchical data structures. Trees are called hierarchical because one of the connections gives more hierarchy, like our grandparents than our parents than we. Here you can see an example as 2 is called the root or the parent, then it has two child 7 and 5 which are called left and right child correspondingly, and then the 7 has two childs 2 and 6 which are called right and left child, and so on. Now to understand the binary tree. A binary tree is a tree whose elements have at most two children is called a binary tree. Since each element in a binary tree can only have two children, one children or zero children, we typically name them the left and right child. Here is an example of a binary tree. Here as you can see, A is the root, B and C are the child. Then we got the two childs of B, D and E. Here as you can see, in D there are two children, H and I. In E there is only one child, and in F there are no childs. Now we can understand the forest. Forest. A forest is a set of n greater than equal to 0 disjoint trees. As the definition says, a forest is a set of disjoint trees. As in the real world, a forest is a collection of trees, and such that is of a forest is also the same in a data structure. When we remove a root from a tree, we will get a forest. Example, removing the root of a binary tree will get a forest of two trees. Here is an example to help you understand that better. As we have understood the forest, now we can understand the M-way tree. M-way tree or a multi-way tree is a tree that can have more than two children. A multi-way tree of order m or an m-way tree is one in which a tree can have m children. As you have got some grasp of a multi-way tree, now we can understand the example. As here you can see a m-way search tree, or where m is equal to 5. It's a search tree, so it will help you search the elements inside the tree. And here you can see there are multiple elements on each node and they follow a different set of hierarchical rules, and we will explain them in a later video. Now we will come to the most important part, applications in the real world. Well, these efficient data structures offer a lot of applications, but those are not possible to be explained on the small video, and here we are explaining only 3 of them, which include social networking websites, big data and big web scrapers, and operating system storage. Social networking websites. A social networking website such as Facebook, LinkedIn, Twitter, as you all know, are using tree and graph data structures for their data representation, because not only it is a good way of representing their data, but also it is a fast and a safe way to represent their data with no latency. When you work on adding two people as a friend, you are creating a forest of two people. Now as you have seen the logo, now we can turn to the big data. It's a hype now that big data is what is big data and how it is managed, but no need to worry, we will explain it. Big data is managed with the help of efficient theorems and efficient data structures made by scientists that can help the data to be organized well and can be searched easily. Websites are organized in the form of tree data structure, where the main page forms the root node and the subsequent hyperlinks from that page represent the rest of the tree. When scrapers scrap multiple such websites, they represent it in the form of a forest of several trees. That's a quite efficient way if you ask me. Now Operating system storage. If you are working on a Windows based operating system, you would be able to see various disks in the system such as C drive, D drive, etc. You can think of each drive as different trees and collection of all storage as the forest. Here, as you can see, that this data structure is quite easy to search with, and it's quite efficient with the searches. Therefore, operating systems also use this, and now you can know that the speed is very efficient of these data structures. Now it's time to take a detour and to see you again on the next video. And please subscribe our channel. We will inform you about more of the computer science things which are with our mentors who are quite good in it. Thank you for listening.